All right, listen, guys. Let's pick up with the rational root theorem. You guys have come to attention here. If you would, by the way, with your test folders, just make sure you have written out the blue marker get around. Yeah. Oh, who needs a blue marker? Okay. Make sure it gets over here too. There are a couple blue markers out there. I need to get the blue markers back. If someone at your table would collect the folders, I'll come grab them later. I mean, you'll be forgiven. You'll be forgiven. But do you need a blue marker?
I already wrote it. I can go over.
No, it's all right. It's not that important. Okay. All right. Let's talk about the rational root theorem. Are you ready? So, in the challenge problems that you picked up today, you will. Thanks, guys. Thank you, guys. In the challenge problems that you picked up today, you'll have an opportunity to prove, almost all the way, prove this result. But right now, I'm just going to present it, and you can think about why it might be true. If you have a, I can take. I'll come get them later if you want. If you have a polynomial, like how about this one right here that we're looking at down here, then if it has rational roots, and that's a big if, this only applies to possible rational roots that it might have. If it has a root that's a rational number, then it must be of the form p over q, where p is an integer that divides the constant term, and q is an integer that divides the leading coefficient. That's what this says. I'm just reading it to you. So in particular, here's the list of possible numbers that could be rational roots of this polynomial. So possible, I'll write for shorthand, possible rational like that. How about roots? Okay? So I might start by thinking about what factors of -3 and 4 exist. So what things divide nicely into -3? And I want positive and negative numbers. Not very many. Plus or minus 1 and plus or minus 3. It's a very kind of short list there. And what about 4? It's a little more interesting. Plus or minus 1, plus or minus 2, and plus or minus 4. All right, so this is how this goes. I might do it in an orderly way. I might think, okay, so we have 1 divided by all of those things in our list. We could have plus or minus 1 over 1. We could have plus or minus 1 over 2, or we could have plus or minus 1 over 4. Okay, those are all the possible rational roots where 1 is the numerator. But we also have 3 as the numerator. Plus or minus 3 over 1, plus or minus 3 over 2, and plus or minus 3 over 4. So let's be clear in what this theorem is saying and what this theorem is not saying, okay? If a number is a root of this polynomial and it's rational, then it must be in the list we just wrote down. You hear me saying that? So in particular, this cubic could have roots not on this list, couldn't it? Like, for example, what? What's
square root of 2.
Yeah, like what if the square root of 2 is a root of this? Right? That's not necessarily on this list. Or if it's pi, yeah. Yeah. Or if it's, what else could it be too? It could be imaginary too. Do you agree? It could be a non-real too. So I just want to make sure we're hearing this properly. If we have a rational root of this polynomial, then it is on this list. Okay, that doesn't mean that we've these are the only possible roots this could have. That's just not true, right? So make sure you're hearing me. It's only from the set of possible rational roots. This is the only ones that could exist. Okay, that being said, can you answer the second question? Someone comes up to you and is like, I think that 1/5 is a root of this. You might say what, Eric?
5 can't be a factor of 3, which is the leading coefficient.
Yeah, you might say 1 divides -2, good job, but 5 doesn't divide 3, right? Would be a good way to say it. if someone comes up to you and says like, I think that 1 plus root 3 is a root of this, then you're like, okay, maybe. I don't know. Because that's irrational. I don't have anything to say about that. I don't know. But if someone comes up to you with a rational number, like 1/5, and says, I think this is a root, then you have like a test here that like rules it out. Do you see why? So you can explain it that way. Like Eric said, you could say 1 divides -2, but 5 does not divide 3, right? And that's required for the rational root theorem, right? And we should also maybe say too, 1/5 is a rational number, therefore this must be true. Yeah. Shh, guys.
You can't
Here.
just have like one number, so we can't have like why can't in the first one why can't 2 be a possible?
Yeah, so 2 can't be a possible rational root because it's not of the form p over q, where p divides the constant term, -3, and q divides 4, the leading coefficient. Do you agree that 2 is not of that form?
What is q? What is
P is the numerator and q is the denominator of our possible rational root. P, it says, evenly divides the polynomial's constant term,
okay.
and q must evenly divide the polynomial's leading coefficient. So what's your p and your q? Well, your p is maybe 2, and your q is maybe 1, is what you're saying? So if that's true, then it must be the case that p, 2, divides into -3, which it doesn't.
Oh.
Right?
The constant like oh I get
That makes sense? Okay. Moving smartly along. Here's an interesting result that's not, that I don't have anything else to say about. We've already actually talked about this when we talked about end behavior, didn't we? So, right. Moving smartly along. Here we go. Let's talk about Descartes' rule of signs. That's more interesting. And this is going to take some unpacking. This is kind of a crazy statement. So we'll try and like understand what that means. And someone should like suggest something that they know about Descartes too, just to remind us about like our context in the world. Does anyone know anything about Descartes? What?
He's a French philosopher and mathematician.
Very good. Yes, both. He's French and he's a mathematician, of course, because he's doing math right now. And he's also a philosopher.
existentialist stuff.
What did he? Yeah. What's his famous quote?
I think therefore I.
One of his famous quotes. Yeah, exactly. Is I think therefore now in math, he's responsible for something that you use all the time. It's called the Cartesian coordinate system, right? Cartesian as in Descartes. So this is that same Descartes. His first name is Rene. Yeah, even though he's a boy, okay, just go. Yeah, it's French thing. Okay, it's a French thing, I guess. Rene Descartes. So you have to like say, Rene Descartes. Yeah, exactly. All right, that part was fun. Understanding what this says is maybe a little harder. Okay, so consider an f of x a polynomial written in standard form, and we'll use this example down here to guide us through what the statement says here. So f of x is conveniently already written in standard form. Wonderful. And now here's what we want to do. We're going to like go by with like a little sonar, a little sign changing sonar. We're going to look at the sign, S-I-G-N, of each of the coefficients, and we're going to look for sign changes as we go from left to right. You ready? And here it goes. Beep. Did you see why I said beep? Because it's negative until the coefficient is -1, but then here it's -2. I mean, it's +2. So it changes. Sorry. Sorry. It changes from being negative coefficient to a positive coefficient. So you with me? Here, let's do it again. Beep. Still positive. Beep. Beep. Did you see the 3 beeps along the way? I count 3 sign changes in f of x. And I'll tell you what that means in a second. But do you count 3 sign changes too? Put it in standard form like it is there. And then go from left to right looking for sign changes. Make sense? One of them happened right there. One of them happened right there, and then the third one happened right there. Isabel? You alright?
Oh, I was just wondering why there isn't an E case as an S and zeros.
I think it's optional. Did you? Yeah, I know, right? It's kind of crazy. I've thought a lot about that because I teach math, but I don't know. English, man, it's hard. Yeah, it's optional. It's up here. It's up here too. It's been up there a whole lot. I know. You can write it with an E. Okay, so 3 sign changes in f of x. Here's the big news, though. This is what that means for us. It means that this is for real zeros. Let's keep in track. We're trying to keep track of rational zeros. We were just talking about. Now we're talking about real zeros. It says the number of positive real zeros. And by positive real zeros, I mean the number of times that it touches the x-axis on the positive side. You with me on that? Is equal to the number of variations in sign. Or, this is a little bit weird to say, or less by some even integer. All right, so what that means is the number of zeros on the positive x-axis, the number of times this might touch the x-axis, is 3. So this means that this has 3 real positive zeros. Or less by some even amount, like 1. So we're going to say this has 1 or 3 real positive zeros. Okay. If there were 5 sign changes, then we would say 5, or possibly 3, or possibly 1. And I want you to think about why there's this like off by 2 thing happening. It's a little bit weird that that's happening. Well, no, the same thing's going to happen with if it was even. If we got like 4 sign changes, then it would be 4, possibly 4 roots on the positive side, or 2, or 0. Does that make sense? Yeah, Isabel? All right, now what about the other side over here? We're going to look at the negative x-axis in a second. Are you good on that?
Yeah, I was just going to say why I think that it could be converted by an even.
Oh, you have a reason?
Yeah.
What do you think?
But I don't know if I'm right.
Just shoot from the hip. Go.
Because the root could be root.
Okay, yeah, it has maybe something to do with, let's see. I mean, you might even just kind of draw some pictures and see if you could come up with a polynomial that this doesn't behave. If we have a double root, that actually counts as one of those. So, yeah, so that's not the reason necessarily. But all right, now I'd like to look at f of negative x. Right here, f of negative x. And by the way, what is f of negative x? If f of x is my favorite polynomial, what is f of negative x?
X is negative.
It's my polynomial flipped over the y-axis. So does it make sense that now if we look at this polynomial, f of negative x, that we're going to like be counting the number of sign changes? We're going to be looking for actually the negative roots of the original polynomial. All right, so what is f of negative x? I need to like write this somewhere. I don't have room down here, so I'm going to write it up here. I get that it's this, x to the 5th plus 2x to the 4th minus 7x cubed plus x squared plus 4x plus 1. Check me on that.
Why isn't there a minus at 2x?
F of negative x. So we're putting in a negative x. You put in a negative x in for all the x's in parentheses and then simplify. So that's why the negative gets killed here. We're not doing negative f of x. We're doing f of negative x. Is that clear? Okay. And remember, if we had gotten the same thing, then it would have been even, right? But we didn't. All right. So now we do the same test. Are you ready? Beep. Beep. I get 2. Did you get 2 beeps?
Yeah. That means it has to be 1, right?
All right, so 2 sign changes in f of negative x. That means for me that we have either 0 or 2 real zeros on the negative side, real negative zeros. I don't know where to put the adjectives. Okay. Negative, that's pretty good. That's my new favorite word. Negative. All right. All right. So now the next higher level question is like why? Why is this even like something we're talking about? Is it useful? So I'll give you a couple situations where this could be useful, right? First of all, if we're on the hunt for zeros, then we know this function, say it doesn't have any non-real solutions, then we think it has 3 crossings on the right side and 2 crossings on the left side. Now if it has any non-real solutions, then we might be off there, right? And again, I might ask you, why is it that we might be off by 2? Okay, it's an interesting question, soul searching. What would be really useful to me is if one of these came out to be 0, right? What if we just had no sign changes in our polynomial? Like say we did in just straight up f of x, we had no sign changes. That would mean it does not cross. Like certifiably does not cross the x-axis on the positive side, ever. So like if you're on the hunt for ones, like just don't bother even looking there, right? Or the same could be true of f of negative x. Maybe you find that f of negative x has no sign changes, in which case that's actually like really, you might be like, oh, a dagger. But actually that's like a really important piece of information because you don't even have to check any negative roots at all if we're trying to like look for them. Yeah.
Does this count for crossing at the order 0?
Yeah, how does that get counted here? What do you think?
Would it be in the positive? Or just not be there at all?
Yeah, I think it would get counted in both of them, right?
Okay.
And that would be okay. But I have to think about that. Yeah.
It just says dagger. Is that a universal thing?
Yeah, in our math formula.
Oh,
There is like a history of that, and I can talk about it later. But all right, are you ready to factor? Let's have some fun here. It's Mr. Davis who actually brought that up. Yeah. Are you ready to have some fun? Here's a 5th degree polynomial, and notice it's like got a period at the end. The only instruction is factor.
Oh shoot, class.
Is it over? Oh yeah, that's true. All right. Good luck with that. How do we factor that? What might you start by guessing at? If I've been nice to you, maybe we have some possible. Yeah, maybe we try plus or minus 6. What else do you notice? Descartes' rule signs. There are no sign changes. What does that mean? In f of x. So that means those aren't actually possible rational roots, the positive ones. So now if there are any rational roots, like if I've been nice to you, which I hopefully have because otherwise this is like a nasty problem to just throw at you, then that's a really short, nice little list to start with. I might start with -1 and try it. Actually plug it in.
That's when you use the guess and check.
Right, so this provides like a list of options, right? I'm going to try -1 and see. Does that make sense? I know the period's going to end in a second, but and see if it works. Right? Try it. If it doesn't, no big deal. Try the next thing, -2. And if not any of those 4 work, then like I don't know what to do next. Right?
Yeah, it works. It works.
Does it? All right. I wish we could do more.